Hello everyone. We're going to learn about the magical ANCOVA today. ANCOVA is so powerful. It helps us make fairer comparisons between while we're looking at our dependent variable. So we are able to control for something else that might be influencing our data. It's really amazing. So for example, let's say that we're researchers and we're comparing the size of girls' brains versus boys' brains. So our dependent variable are the size of brains, and our independent variable are our groups, the girls and the boys. And we find boys have bigger brains. Well, what else could be influencing the size of boys' brains? Their weight, right? How big they are. Men are generally bigger than women. I should say men and women. So what if I could control for weight and saying, given weight to be equal, let's pretend everyone has the same weight. Now let's compare the size of brains between men and women and see if we have a better comparison. Let's see if we can control for that and now see what the adjusted sizes are. So that's what the ANCOVA does in a nutshell. So what I'm going to do, I'm going to walk us through how to do this on JMP and how to think about our data. We do have more assumptions to do here, and so there's a little bit more to walk through. So this is going to be a little bit longer than some of the other videos, but that's okay. Bear with me. So let's see here, JMP. So I'm going to pull up the data set ANCOVA practice by Mofield. And my research question is basically like, okay, if I look at evaluation scores, I'm wondering, do people with doctorates, masters, or bachelor's degrees have higher evaluation scores? So my null hypothesis would be there is no statistically significant difference in evaluation scores between the groups. Now that's just a plain old ANOVA, right? Because I've got 3 groups and my dependent variable is the evaluation scores. However, I'm going to add the phrase when controlling for class size. So I'm wondering what else could be influencing evaluation scores besides the educational level? Well, it might just be because they have small classes. That could be a factor. Like all these people with 4s and 5s with really high scores, maybe that's due more to the fact that their class size is smaller and rather than education level. So that's the gist of what I'm going to do with the ANCOVA. Now, here's a few things. The dependent variable has to be continuous, and the covariate class size has to be continuous data, coded in blue, meaning there's a range of scores. These are not categorical variables. So when I look at my write-up comparisons guide, I have a few assumptions to go through. Okay, first, this data is random and independent. Number 2, the dependent variable and the covariate, they are normally distributed among all the groups. So to do that, what you do, to remind you how to do that, you go analyze distributions, and then you put in both your covariate and your dependent variable. And we're going to split that by educational level, by independent variable. And what I do, I'm going to skim, and skewness here is a negative 0.11. I'm good. Look at skewness for doctoral level. It's right there at a 1. Skewness for masters, right there at a 0.77. So I'm good. Now let me slide over here and look at this data. This is for this should be for the covariate of class size. Okay, no, that's what I did before. Where's my covariate for evaluation scores? Here we go. Oh, that's an interesting number. What is that? Well, that's really like 0.000006. That's what that means. So that's between 1 and -1. All right, skewness is good there, -0.59, and skewness is good there. So my normal distributions assumption is met. Okay, next, check that off the list. I need to make sure my covariate and my dependent variable relate, that they are correlated well. And I need to make sure that they do relate to each other, at least at a level of plus or minus 0.20. So I do a correlation test very quickly, multivariate methods, multivariate. I'm going to slide them both in, class size and evaluation scores. Let's just check out that R value. It's a -0.76. Well, what does that mean? As your class size goes up, your evaluation scores go down. It's an inverse relationship. The more kids you have in class, it's harder to teach. So your scores are going to go down. So it's a pretty strong negative relationship there. So that assumption is met. Next, I look at homogeneity of variance. I'm going to do a Levene's test, but I'm just going to do it for plain old ANCOVA, the plain old ANCOVA way to do it without adding the covariate. So I'm going to do just like the plain old Levene's from a long time ago that we learned. So go analyze, fit y by x, and I'm only going to look at my independent variable and my dependent variable. I'm not even going to worry about the covariate right now. Evaluation scores, okay? And I'm doing the Levene's test. And I'm making sure that the p-value is above a 0.05 because I don't want there to be differences in the variance. I need to make sure I'm comparing good equal samples. So I'm good there. So homogeneity of variances, that assumption is met. Next, homogeneity of regression slopes. Okay, now I am doing this based on what I've been learning in Hatcher and a number of other statistics books I've been reading. This is something I have recently learned to test for this interaction. And so you can read about it in Hatcher that you want to make sure there is not a statistically significant interaction going on with the way these with slopes. And I'm going to show you what that looks like on JMP without getting into too much detail. So what I do, I go to Analyze, Fit, Model. And so my dependent variable is evaluation scores. And I'm looking at differences in education level. And I'm going to add my covariate, class size. But I'm also going to look at the interaction of these two. And this interaction is going to show me what's called the, it's going to allow me to see something about regression of slopes. And so what I'm going to do, I hit class size and education level at the same time by hitting control, and I'm going to do cross, and that gives me the interaction. So when I click run, I'm still just doing assumptions right now. I'm going to go and I'm going to look way down here. And I want to make sure that this right here is not significant. It should not be significant. And it is not significant. Ooh, it almost is. So we want to make sure this p-value right here of the interaction, we want to make sure it is not significant, because if it were significant, I need to be more cautious how I proceed, because it means that this assumption for the homogeneity of regression of slopes is not met. So this is saying the regression of these slopes about the relationship, they're pretty similar, they're parallel. And so actually looking right here is what it's doing. It's saying, are these lines a fit for each level? When we look at class size and evaluation scores and we see how they're correlated, are they correlated similarly at each level? And they pretty much are. Now you can see how it was close where they might start interacting. That's what the interaction is doing. Like, are they interacting? because if they're interacting, we cannot resolve this assumption. So that's what that assumption means, if you want to know. All right, but procedurally, we can move on. Yay. Next. When conducting the ANCOVA, we need to make sure the lack of fit is also all right. So I should not have closed that out. So I'm going to do this. Oh, did I close it? Maybe I could just, oh, here it is. Okay, before closing it out. Oh, this is a different version of it. Okay, I'm going to just do it again. So I do that fit model. Remember, teacher effectiveness. That is the, nope, that's not it. Better slow down. All right, evaluation scores. That's my dependent variable. Education level is my group. This is my covariate. Okay, and I'm going to go on and put that interaction in again. Class size and this. Okay. All right, so I would have saved some time if I hadn't closed this out, but then we have the lack of fit. I want to make sure that this number right here is above a 0.05, and it is. So I'm good. All my assumptions are resolved. Wow. Okay, that was a lot just to, before we even do the ANCOVA, that's a lot of hula hoops to get through, isn't it? All right, so now what we're going to do is we write up our assumptions, and it's probably a good idea to go into detail about those assumptions when you write this up. I wouldn't ask you for your dissertation to report the skewness of every little thing, which, by the way, those numbers I might have just made up instead of copying all of those descriptives. But you probably wouldn't report all those little specifics, but I would report the specifics of the beams, the regression slopes, and to making sure that the correlation is above a 0.20 or minus 0.20, okay? So I would write that. Now, here's what you do. Here's what you want to do. Think logically about this. First, we're just going to do a plain old ANOVA to just see, are there differences in evaluation scores between the three groups? And I just want to like wrap my mind around it and see what's going on. So I'm just going to do a fit y by x. And we're going to do education level. And I'm going to look at my dependent variable, which is evaluation scores. This is a plain old ANOVA. Let me just see if there are differences somewhere within these three groups. And when I look at my ANOVA right here, it is statistically significant. I'm going to write down this F value. F equals 5.86. Okay? And I'm also just going to pay attention to this error. Just to note, this is the amount of variance going on within each group. It's 30.23. Okay, I'm just going to take note of that, and I'm just going to skim these means. Bachelor's, 2.50. Doctorates have the highest. Okay. All right, and so I'm just inspecting what the plain ANOVA finds. But remember, now I'm wondering, what if I had a covariate here and make everybody equal on class size? Like everybody has 20 kids in their class. Then what would I find? Well, that's what's so magical about the ANCOVA. So we're going to do analyze. We're going to do fit model. And we're going to continue to put our dependent variable up here in y. I'm going to put my educational level down here, and I'm going to add the covariate. However, this time around, I leave out the interaction because it was not significant. I don't have to worry about homogeneity of, I can assume a homogeneity of regression of the slopes. So everything I have been reading and studying says that if those slopes, that interaction was not significant, then your ANCOVA, you simply add in this covariate here. All right, so, and you know, I would say that there are different approaches to this. This is the approach I personally feel most comfortable with right now from the studying I've done. Okay, so now what I'm going to look for, I'm going to see what just this model produced. Now, this time, when we include the covariate, it's super significant. this error term went down quite a bit, which makes the F bigger. Do you remember the F represents between group variance over within group variance? Well, when the within group variance is smaller in the denominator, it makes the F bigger. So it really did impact the overall model here. Okay, so we definitely see the covariate has an impact. But what's of real interest to me is down here. This is really where you need to study. So right here, it says education level. This is now really showing me, okay, when a covariate is added to the model, are there differences in educational level? And yes, there are still differences. This is what it's showing. And the F for educational level is showing reject the null hypothesis. When we include class size in the model, there are still significant differences. This is showing here. This is showing that class size also definitely impacts evaluation scores. They are both working together. And if you really want to know something neat, ANCOVA is like the same thing as regression. It's a different persona. ANCOVA is regression in a different persona. And here, if we want to look at this a little bit differently, we could think about these things as predictor variables. That if you have a doctorate level degree, that is predicting your evaluation score to some extent. The class size is also predicting the class size to some extent. If you really want to know some neat things, this standardized beta here, these are like partial correlation coefficients. So it's like they're all interacting and sucking up the effect they have each other, so we can see the clean contribution of each variable on evaluation scores. Now, the other cool part to look at, the really cool part, is the magic wand part, and that is right here where it shows the original means right here, but now as we equalize them all, it shows them here. And what this ANCOVA is saying, because the educational level was significant, this is saying that even when the means are adjusted, y'all, there's still a difference. Like, look, you see the bachelor's level, it was adjusted up to account for class size. This was adjusted a little bit down. This was adjusted, but even when they're adjusted, even when this covariate was added, there's still a difference. Isn't that cool? So if you're like, but where's the difference? Is there a little Tukey or something we can do? Is there a little post-hoc test we can do here? All right, so you go here. You could do a Tukey's test, it's a little more conservative, or you could do students' t-tests. But what this is showing you, it's showing you where the differences are. So between doctorate level and master's level, there are differences. That's what this is saying. Between master's and doctorate, there are differences. That the doctorate level people compared to the master's have higher scores. So that's where the post-hoc tests come in. Well, how do you write all this up? Okay, so after some great studying and redoing and rewriting and revision, this is one possible way to do this. But listen, do not copy and paste from here. Usually in doctoral research, you figure out how to write it. Like there is not a set template. You look at what other people have written. You can look in your Hatcher text, but this is one approach. This is an example, and this will hopefully help you know what to look for.